taking a look at number 4 from rational functions number 1, without using our graphing calculator, we're going to identify the vertical and horizontal asymptotes, the x and y intercepts if they exist, and any additional points that allow us to graph this function. So the first thing I'm going to do is I'm going to rewrite this. I'm going to factor out a 4. I can see that's an obvious. I cannot factor out a 2, so I will leave it as is. Now, let's first identify the degree in the numerator, which is 1, and the degree in the denominator, which is 1. Degree is going to be the highest exponent on a variable. So a degree 1, degree 1. When the degrees are exactly the same in the numerator and the denominator, we are able to identify the horizontal asymptote, which is always going to be y equals some value if it exists, by taking the ratio of the leading coefficient in the numerator divided by the leading coefficient in the denominator. So 4 divided by 2 is 2. So I'm going to come over here, I'm going to go to positive 2. As a reminder, our function can and will sometimes cross or touch a horizontal asymptote multiple times. It will never touch or cross a vertical asymptote. Now, how do we determine a vertical asymptote? Well, a vertical asymptote exists if there's any variables in the denominator. I'm taking that quantity, setting it equal to 0, and then I'm going to solve. So I get 5 halves by dividing by 2. I get 5 halves, which is the same as 2.5. We do want to write it as a decimal. We do want to write it as an equation. So whether you write x equals 5 halves or x equals 2.5, those are similar. So just equivalent forms of the same value. All right, now next, how do I determine if any x or y intercept exists? If there's a variable in the numerator, we're setting that quantity equal to 0 and solving. We could also take in 4x plus 8, set it equal to 0 would get the same thing. I'm moving x to the opposite side, and one of the x-intercepts occurs at -2. So I'm going to -2, which is right here. That already tells me, by the way, that I know that I'm going to have a graph down here. Now, how do we determine the y-intercepts? So whenever you determine a y-intercept, x is always 0. So let's go up to the beginning. If I substitute in a 0 for x, I get 0 here, and I get 0 here, and I have 8 over -5. So 8 over -5 is my quantity. Now 8 over -5, I know that it is a fraction, but if we think about it, 8 divided by 4 would be 2, but this is just, 8 divided by 4 would be 2. This is just 5, is just a little greater, so it's going to be just a little less than 2. So this is going to be, this quantity is just going to be a little bit less than -2, this quantity. All right, so I'm going to go over to 0 and down just a little bit less than 2. And now this allows me to graph this. So I have an x-intercept at -2, 0, and I have a y-intercept at 0, and then -8/5. Now, if it's here, how do I know over here? Is it down below or is it up top? I'm going to choose one number to the right. I think the easiest number looks like 3, and I'm going to substitute in 3. Now, why can we not substitute in 2.5? We're not actually going to choose the vertical asymptote value because we know the function never touches or crosses that. So let's substitute in 3. 4 times 3 is 12, and 12 plus 8 is 20. 2 times 3 is 6. 6 minus 5 is 1, and we get 20. So way up here, all the way up here at 20. But this does tell you that it's in this top portion.